Hello there, welcome to ASFM, the Maths Core June 2023. Here we're looking at question 6. The line L1 has equation of -2, 2, 0, and lambda lots of 3, 0, 1, where lambda is a scalar parameter. The line L2 is parallel to 1, 2, -3. Show that L1 and L2 are perpendicular. So if you want to show that two vectors are perpendicular, you do the dot product of the direction vectors, and that will equal 0. So we need to show that this will equal 0. So let's work this out. 3 add 0 minus 3 equals 0. And because it equals 0, as a dot b equals 0, L1 and L2 are perpendicular. So there we are, that's the answer to part A. The plane pi contains L1 and is perpendicular to 1, 2, -3. Determine the Cartesian equation of pi. Well, if we know that a plane has a perpendicular vector of 1, 2, -3, then we know that the Cartesian form is going to be x using these coefficients, x plus 2y minus 3z equals a certain value d. We just need to know a coordinate this plane goes through, and then we know we can work out the value of d. If we go back, we can see that the plane will be containing L1 will go through -2, 2, 0. So we're going to substitute in -2, 2, 0, and we're going to get -2, add 2 times 2, minus 3 times 0 equals d, so therefore d is 2. So therefore the Cartesian equation of the plane is x plus 2y minus 3z equals 2. There we are. Moving on to part C now, verify that A lies on pi. If I want to verify that A lies on pi, I substitute in the coordinate and show it equals 2. So 3 add 2 times 1 minus 3 times 1 equals 3 add 2 minus 3, which equals 2, which equals the right-hand side of 2. So there we are. It's definitely on the plane. Moving on to the big one, question D. Given that the point of intersection between pi and L2 has coordinate 2, 3, 2. So if we visualize this, we know that L2 is perpendicular to it. So I'm going to draw L2 going up in that direction there, and it's intersecting the plane at 2, 3, 2. The point B lies on L2, so this is P, Q, R. The distance of A to B is 2 root 5. Now what we know about A is that it's on the plane somewhere. So A, which is 3, 1, 1, is over here. And we're told that the distance between A to B is 2 root 5. Determine the value of coordinate B. Okay, so what I'm going to do is I'm going to create a coordinate for B using some information I know about the line L2. The line L2 starts at coordinate 2, 3, 2 and goes off in the direction of 1, 2, -3. I know it's 1, 2, -3 because that is the direction vector of, L2 is parallel to 1, 2, -3. So from that bit of information, I know that L2 is going off in that direction. So what I'm going to do is I'm now going to combine these two parts of the direction vector together. And we're going to call this coordinate B. So for some value of mu, it does reach PQR. Now I need to work out a vector to get from A to B. And to get from A to B, you do B minus A. So it's going to be 2 plus mu, 3 plus 2 mu, and 2 minus 3 mu. Take away the coordinate for A, which is 3, 1, 1. Let's just double check that. It's definitely 3, 1, 1. Yeah, 3, 1, 1. So when we do that subtraction, we're going to get -1 add mu, 2 add 2 mu, and then 1 minus 3 mu. Now the next thing I need to do is calculate the magnitude of this vector. So it's going to be the square root of minus 1 plus mu squared, add 2 plus 2 mu squared, add 1 minus 3 mu squared, and that distance, that magnitude, is 2 root 5. First thing I'm going to do is square everything to get rid of that big square root and open up all of these brackets. So it's going to become 1 minus 2 mu plus mu squared plus 4 plus 8 mu plus 4 mu squared, add 1 minus 6 mu, add 9 mu squared, equals, and 2 root 5 squared, let's get the calculator out so I don't get this wrong, squared gives 20. So let's create a quadratic on the left-hand side. So let's do the mu squareds first. 1 plus 4 plus 9 is 14. So 14 mu squared. Then it's going to be minus 2, add 8, minus 6, gives 0. So there's 0 mu's, and it's going to be 1 plus 4 plus 1 minus 20. We give minus 14 equals 0. So this is a pretty straightforward one to work out. Let's move the 14 to the other side, and we get mu is plus or minus 1. Now, we know that, so we'll highlight this line actually, P, Q and R are positive integers. So we need to now use the correct value of mu to get positive integers. So when mu is 1, B is going to be coordinate, and I'm going to use this thing here. 1 plus mu, so 2 plus mu would be 3. 3 plus 2 is 5, and 2 minus 3 gives minus 1. So it might not be that coordinate, because if P, Q and R are positive integers, minus 1 is not a positive integer, so it's not that coordinate. So when mu is minus 1, B is going to be coordinate 1, 1, 5, which is the correct value of B, because they're all positive integers there. So there we are, that's the answer for question 6, worth a total of 11 marks. Let's now move on to question 7.